Hello everyone, good morning, good afternoon, wherever you are in the world. This is Dante Ferrari from Fluidtech. We are going to now start this new topic, lubrication factor using vibration analysis. And for that, we will introduce Will Ocean, Managing Director at Maintain Reliability, who will tell us all the secrets. So, Will.
Hello.
Welcome.
Thank you very much. It's an honor to be a part of the event. Hope everyone's keeping well. Again, lubrication reliability, something I've been heavily involved with for a long time. So it's an honor to be speaking on the platform. Hello, everyone who's joining as well. This for me is an incredible opportunity to be able to show people something that I've heavily been involved in the last year or so, and we've not really shouted about it a massive amount in terms of kind of exposure, but now we're kind of really ready to be able to let everybody know kind of our findings. We've got a couple of really good case studies as well around this. And yeah, what we're going to do as well is get into a bit of a presentation as well, so we can show you what's going on here. I hope you can see the screen. I hope you can see me. So just a quick introduction to who I am. If anyone doesn't know, my name is Will Ocean. I'm Managing Director of Maintain Reliability. Maintain was formed about 6 years ago, and it was just myself. So it was just me with a very big dream and a big passion to be able to help people in the industry with reliability. The last 2 years, we have grown ridiculously. The scale has been incredible. I'm very grateful to be a part of an incredible industry as well. We get involved with a lot of different things in terms of reliability. We've kind of created a detect, solve, improve kind of model. So for us, detection is more in the essence of condition monitoring and using techniques like vibration analysis, ultrasound, thermal imaging. The solve part is more to do with the solution. So how can we solve it? How can we go in there? Can we actually change the bearing? Can we actually solve it rather than giving you problems? Improve is then going into proactive natures of what we're doing. So that can be better reliability, understanding applications. How can we make the asset last longer? And that is an extremely important part of us being in part of reliability as well, because being proactive, which really does tie into this lubrication part, was something that we found within the industry a lot, where our detect would identify a lot of issues that we're finding poor lubrication with, whether that be with ultrasound or vibration analysis. And what we wanted to do is be able to offer the improved part of it, to understand, well, how much lubrication is actually required to make sure this asset can actually live its long life cycle of what it should do. And how do we know their metrics in terms of measurements of vibration analysis, or would it be ultrasound? So that gives you a bit of an indication of the company and what we're about. Now we're going to go really kind of laser focus into something called lubrication factor. And this reading has revolutionized the way that Maintain actually now approach vibration analysis. And we've kind of actually evolved it a little bit as well. So we don't actually call it vibration analysis now, we call it asset care. So asset care is slightly different to just actually going and collecting data and letting everyone know the problems. What we're trying to do is actually solve the problems by the machine. So if that machine requires lubrication, or we find there's an issue with lubrication, we can actually lubricate that asset by the machine and actually solve that and actually improve the reliability of that in real time next to the machine. Notoriously in this industry, it's always been very kind of, shall we say, a long approach to get to that end solution, in terms of, say, if we go to that machine, we find poor lubrication with that machine, we put that into a report, that report goes into a report that we email to the customer a few days later. They have to then process that report and put that into a work order to then actually send the guy out to lubricate the machine. In my mind, that's a very long-winded way to be able to get to the solution. But in order for us to be able to be confident that we can lubricate alongside the machine, we need a reading, or we need a metric to understand that there is poor lubrication, so that when we do lubricate that machine, we get confirmation that when we leave that machine, it has the sufficient amount of lubrication in. And this has always been a very big problem within our industry, to be able to detect that. So we've actually created this reading, and we're going to show you kind of a lot more as well. So in this presentation, what we're going to do is take you through the introduction. We're going to take you through schedule-based lubrication, which has always kind of been predominantly a thing before condition-based lubrication has come around. Predominantly, a lot of people are still kind of lubricating based on schedule. Okay, I'm not saying there's nothing wrong with that if that is, accurately put together, but there are some disadvantages of doing it that way as well. So we've got lubrication with ultrasound. So now we're going to go into ultrasound as well, because obviously ultrasound has always been, shall we say, king of the conversation when it comes down to identifying poor lubrication, because it can measure such a high frequency. Okay. Then we'll get into lube factor with the one prod Falcon. Here's the Falcon. Obviously, this is by Aquam. This is the collector that we use. This piece of equipment has allowed us to be able to create this reading because of how high it can actually measure in terms of a frequency range. And we'll get into that a little bit later. Then what we'll do, we'll go through a case study of where this was put into practice. There's 2 case studies as well. And at the end, we can go through the settings and parameters if we get time. But that's kind of the boring stuff. Let's get into the good stuff, okay? So introduction, right? You know, they say that 1/3 of all bearings fail due to poor lubrication, and that is in line with SKF's article, Bearing Damage and Failure Analysis. Okay, so this is a proper article. You can see that online. There's so many factors that contribute to good lubrication practices, but being able to lubricate a bearing, the exact amount of grease has always been a challenge. Okay, it's always been something very difficult to do within the industry. This always leads to unaccounted costs or labor due to premature bearing failure, which, you know, if we were detected, it wouldn't have happened. And again, if we have a look at how many times a bearing is starved of lubrication over the period of time, if even in regreasing intervals on the schedule base, if we was able to enable that bearing to be sufficiently lubricated all the time, the life cycle of that bearing could potentially live 10 times longer. And that kind of study is quite phenomenal in the sense of how many bearings do we have out on plant, how many require lubrication, and what practices are we applying to them bearings within that standard or that maintenance practice as well. Okay, so lubrication is often overlooked. Again, we find this a lot. I go to a lot of factories, and again, when we have a look at lubrication, if we have a look about how much money is invested in that one practice, what I tend to find that is very underfunded in terms of what it is, whether that be stores in terms of how even the lubrication is kind of kept in terms of oil stores. If I have a look at lubrication guns or look at the equipment that they use to lubricate, then if you have a look at the schedules and how much money they've spent in terms of actually creating the schedule and putting some data or knowledge to them schedules as well. So we do find that this, you know, is a very underfunded kind of part of reliability, and conversely, it's probably the part that will give you the most proactive kind of longevity out of your assets if it is done correctly. Okay, so we've found that current methods of lubrication can result in inconsistent grease applications. All right, so what we believe, we found a simple way to actually accurately measure that lubrication in the bearing and precisely lubricate it with the exact amount of grease it requires, then leave it alone. So that way we don't actually start to over lubricate the bearing as well. So over lubrication is another thing, another subject that we could talk on for hours and hours. And over lubrication is another subject that I probably will in the future as well. And again, we've done a lot of podcasts on this. Again, if you don't follow us, follow the Reliability Gang podcast. We talk in depth about these details and issues in terms of what we find within the industry, especially when it comes to lubrication. So find us, the Reliability Gang podcast. We're on Apple Podcasts, we're on Spotify as well. Have a listen to some of them other subtopics as well that, you know, are really interesting. So that leads us to the next part. So let's have a look at schedule-based lubrication. So what we'd consider to be a traditional approach to lube is lubrication that is based on a schedule, a time-based schedule. So this is a regular basis. So whether the bearing requires it or not, it is lubricated on a time base. So say, for example, you've got one motor on your plant. It's a very critical piece of equipment. And the schedule says that that motor will get lubricated once a month. And say, for example, it's 5 grams of grease it requires. There's no kind of looking at whether the application requires it or not. It is just done on a consistent basis and it is lubricated. Okay, it's very easy to be able to put that into action, but in between lubrication intervals, how do we know whether it has enough or hasn't? Or how do we even know that it's even enough in there anyway? It's very, very difficult to understand that that bearing has the correct amount of grease in when it's done on period, when we do not understand the metrics of that machine. So measuring in terms of monitoring is extremely important anyway. Again, this comes down to kind of looking at strategies of what you've got with your critical assets in terms of how is this actual machine being monitored in the sense of vibration. And vibration, again, if you're looking at high frequency vibration, it's still vibration. You're still looking at kind of lube film and understanding high frequency elements as well. And soon as them parameters start to get out of sync with what is normal, then it creates an alarm for us to understand that action is needed to be able to lubricate that bearing. Okay. So lubrication with ultrasound. So again, ultrasound typically has always been, shall we say, the number one main kind of technique to use when doing condition-based lubrication, purely on the sense that it can monitor a lot higher than what vibration analysis can. So typically when you're measuring around about 20 kilohertz or above, you know, this is interpreted as an ultrasound reading. And again, ultrasound is a friction-based event. So when we're looking at friction-based event, we're looking at extremely high frequencies. Again, this is why ultrasound has always been a very good technique, right? So an individual experience of lubrication, and we know that bearings and the machines well, we can understand how much grease we can put into that. And therefore, a level experience is required when you're using ultrasound as well. Because the thing is with ultrasound as well, especially most basic ultrasound devices, it will give you a decibel readout, and it will just give you a readout, okay? Again, in terms of frequency range, you're measuring not a band, you're measuring up to a certain frequency range. So with the UP 10,000, for example, piece of UE equipment, they say that 30 kilohertz is the contact probe Fmax that you want to be listening to contact bearings or poor lubricated bearings. But the thing is with that, we're measuring naught all the way to 30K. So we're taking into consideration every other sound within that, and with that overall decibel level, will give you an overall decibel level from that area. Ideally, what we want to try to do is band that area. It would be a lot more effective to do so. So if you can band the area, then you just want to be looking at purely the place where poor lubrication happens, and you don't want to be listening to the whole frequency range. Okay, so ultrasound is very good at detecting it, but it doesn't give you an actual indication what the problem is. It will give a sound, it will give a reference, and the user will have to be able to interpret that. And if the user is not experienced with ultrasound or doesn't know what they're listening for in terms of before and after, or understanding what a poor lubricated bearing sounds like without the training, it can be a little bit difficult to be able to ascertain by just using ultrasound alone. So even though it's a great indicator to be able to do that, and again, I don't know, there are some different, you know, manufacturers out there that do lubrication equipment that probably will allow you to band different areas. I'm not sure. But in my experience with a lot of the equipment that we've used, it's been kind of fairly basic in the sense that you would select a frequency range. You as the listener would interpret whether there's poor lubrication. And after you've lubricated, you'd have to be the interpreter to understand whether that has actually reduced or not, which leaves a lot of kind of subjective kind of gray area for you to understand whether that has got the correct amount of lubrication or not. Okay, so it can be very effective, but quite vague in the sense of has this actually resolved the problem or not. Okay, so moving on to the Falcon, we're going to now understand how this lubrication factor reading works. It's a very good analyzer, and the beautiful thing about this particular analyzer, it can measure up to the 20 kilohertz range. Okay, in 10 seconds of time, it can take a very quick reading, and it kind of post-processes a lot of the readings from a single time waveform. And right on the edge of that ultrasonic range, we've found by using that VA, it's really possible to detect poor lube as well by using VA. And we've done a lot of studies, and this is when I first got this collector 2 years ago. We were really interested in understanding that because it can measure up to them high frequency ranges, where would we expect to see the natural friction related events as actual raw data? So what would be the frequency response of that poor lubrication when measuring up to them high frequency ranges? And the beautiful thing about vibration and spectral analysis is that we can actually view that spectrum in live mode, and we can actually start to see how machines react, if that makes sense, in terms of frequency ranges. So where there is a fault condition, we can have a look at where we'd expect to find that frequency response. And what we've actually did is a lot of tests with the wireless sensor that we were given, and we found extremely great results. So when we're testing within the high frequency spectrum, okay, we actually identify between 7,500 hertz and 12,500 hertz. If your hertz, guys, if your cycles per minute, you're looking roughly between 450,000 cycles per minute to 750,000 cycles per minute. This is where the poor lubrication kind of presents itself within the data as like a haystack or a raised floor. So when we're looking at a poor lubrication, we did a lot of case studies with some bearings, and we actually found that haystack start to rise quite rapidly through them areas of a frequency response. So this was the frequency response of a dry erase or poorly lubricated bearing, and that's exactly what we found across a lot of different plumber blocks of a lot of different motors, and we did study after study. So we tested a good 100 to 200 motors that were poorly lubricated, and we found that this was the sweet spot that we were finding the poor lube information. Okay, so when we were viewing that data in the high frequency spectrum, we took live readings, and what we did is actually grease the bearing when it was in live, and we could actually see the frequency response of that film or friction disappearing, which would see the haystack disappear. You'll see where exactly these haystacks appear later when we start to look at the actual frequency responses of the case studies as well. Okay, so this means that what we could do is actually understand very quickly whether that bearing had been lubricated sufficiently or not right next to the machine, which was a game changer. Okay, so we found that the wireless accelerometer as well matched a very good frequency response within that area, and it resulted amplified the signal a little bit more to make it more responsive within that range, which was beautiful for us as well. So we tested that method in the field so many times, loads of different sites, and we got so many different effective results. So what we did is create a band alarm around the 7,500 hertz and the 12,500 hertz, which we called lube factor. And that was the metric that gave us an overall reading. And what we did after taking lots and lots of different data, we understood what was good and what was bad, and we created alarms around them within that band. So that was actually effectively what all it was. It was a band alarm at a high frequency event that we did a lot of case studies around, and that actually evolved to become lube factor. Okay, so here's the case studies. Let's get into the case studies as well to show you guys this in action, right? So this was for basically one of the biogas sites that we look at. We look after 8 biogas sites across the UK, extremely critical sites, and gas booster pumps are extremely critical. If one of these actually fails, then the site struggles to be able to maintain pressure for the gas, and it potentially can, cause downtime. And again, gas, we all know gas prices are through the roof at the minute, and these biogas sites are actually even more important than ever right now due to the economy and everything like that. So this was actually a gas booster blower, and it was one of 3. And working with the maintenance team, we started using the Falcon precisely to lubricate at each visit to make sure the bearing was staying in the optimal range. So if we have a look at the data on the next page, right, here is the information spectrally, okay? So if we have a look at what we've got here, this is our alarm window, okay? And if you have a look here, what we're doing with the Falcon, we're taking triaxial readings. So don't get too confused by these alarm windows. If you have a look here, this is the motor non-drive end, and what we can measure is axial direction, the horizontal and the vertical, and they're the 3 readings that we take on the motor non-drive end. Then the drive end of the motor, as you can see, we've got axial, we've got horizontal, we've got vertical, and on the pump here, again, as vice versa. So we've got 3 axes for both. And that's what we found on the blower pump bearing number 1. As you can see, lubrication factors here, we had a red alarm. So again, if you look at the metrics here, as you can see, a well lubricated bearing is very low. You're looking at 0.02. A poorly lubricated bearing triggers the amber alarm at 0.2, and 0.4 is critical. Okay, so as you can see here, we're talking very low measures. So guys, this is why it's very important to band alarm certain elements, because again, 0.4 doesn't seem very high. But if we have a look within this frequency range, remember, higher frequency ranges, you're not going to get a higher overall value, especially when it comes to friction related events, because you've got a lot of other vibration events happening within that spectrum. It's not necessarily going to actually even trigger your overall acceleration alarm, because if you have a look at where we are in the frequency range, you know, if you have a look at 0 to 1,200,000 cycles per minute, in terms of the whole frequency range, all of this needs to add up to be able to exceed the alarm for acceleration, and it might not actually peak above that threshold. This is why it's very important to be able to create band alarms so you can understand there is an issue at high frequencies. Even if it's a low overall number, we're still looking at a certain band of a frequency range, and if that is a haystack event or something is within that frequency range, i.e. poor lubrication, we know there's an issue or problem. So here, as you can see, within our spectrum in terms of this frequency range, what we see here is a high kind of haystack event. And if you understand how lubrication and friction occurs in terms of frequency response on friction related events causes raised floor properties. So it doesn't actually cause kind of peak related issues. When you've got a friction in the bearing, usually the whole race is dry. So what it will do, it will create a haystack event, and it will start to put that at a very high frequency. And what we are finding, obviously, between our measures of kind of, you know, 10 here, it starts at 10, it's slightly lower down the scale here. And what you'll find, the more poorly lubricated the bearing is, it will actually start to move lower down the scale, which is very interesting as well. Very interesting study that we're looking at as well. And as you can see here, the haystack here is really prominent here in terms of that poor lube. So again, without this lubrication factor, right, if we took out this reading altogether, would we actually really know if the bearing was poorly lubricated? Probably not. Again, the beautiful thing, because we have lubrication factor, our envelope can only really purely look at impact related events or harmonic events for the bearing. So what we can do now is very clearly understand a distinguished pattern between poor lubrication and, you know, bearing defects, which is very difficult to do before, because most envelope spectrums, you know, in terms of filtering, were very wide filters. So you could see poor lubrication events as well as bearing defect events. But the problem is distinguishing between the two was difficult. Whereas now we can separate them two, and we can really see whether it is a lubrication issue or can we see it's an overall envelope issue. So it allows us to keep our banding, our filtering very narrow for our envelope to look at purely harmonic related events, rather than looking at a wider kind of filter range and obviously trigger poor lubrication and bearing defects at the same time. Okay, so after lubrication, this was what happened. As you can see, lubrication factor reduced significantly straight away. And as you can see, that massive haystack, right, if we go back again, you'll notice that even these haystacks as well were associated to that poor frequency response in terms of friction, are completely reduced, right? And that was after 3 or 4 shots of grease. And as you can see there, straight away. And as you can see, just to give you an example as well, acceleration, of course, is going to fall as well, because again, you're looking at the whole frequency range as well. But as you can see, it's only fallen by 0.4. So it's not fallen by a massive amount. So this is why it's so important as well to have a band around them frequency ranges that you need to see. Because when you're measuring at such a high frequency range, you want to be able to look at certain things within that spectrum. Because one high frequency spectrum is just going to give you a lot of information. It's going to be very difficult to pinpoint exactly what you do want to actually see. That makes sense. Okay. So moving on. If you have a look, this spectrum is a very beautiful spectrum because this allows us to have a look at before and after. So as you can see, the blue is the lubrication before, right? Now, as you can see, you can even see a kind of high tail off here as well, which has happened a bit. The main kind of peak is here. And as you can see, the red is after lubrication, right? And as you can see, the frequency characteristics change quite a lot, which is really interesting here. Even at the lower frequencies, you can see a little bit of a shift of the frequencies moving up a little bit, which is quite interesting. As you can see, this haystack is completely reduced. This one here, again, is completely gone. And this one here, which was the main kind of frequency response, is completely reduced. So it is really kind of influential in the sense that we have understood exactly our actions of lubricating that bearing has created a better film for the bearing instantly. And we can now, obviously, with our collector, as you can see, it's gone from red to green instantly. So this is the beautiful thing about the metrics and alarm levels of what we're doing here. It lets the user know that there's enough being in it without any subjective experience of using ultrasound or listening, if that makes sense. And that is so important, because especially when it comes to entry level kind of people that don't understand vibration analysis so much, what we can do is create this lubrication factor alarm, and we can say, look guys, if it goes into yellow or red, lubricate the bearing. If it reduces, then whatever you've done in terms of action has actually cured it. And that is paramount within this industry, 100%. So case number 2, this is getting on to bigger beasts as well. We want to obviously show you an application with an actual motor as well, which is very, again, this lube factor is extremely effective with plumber block bearings. It is still very effective with motors as well. Probably better with larger motors as well, because, you know, again, the smaller the motor, the harder the frequency response will be at them higher ranges. Okay. And if we have a look at this was actually one of our customers in the food industry. Okay. So we provide asset care with 3 of these motors. They've got 3 large compressors, MOD compressors, that are extremely important to their processes. And we use lubrication factor, and we closely trend the lubrication values, and we lubricate as we start to see early kind of signs of lube factor. We start to lubricate as well. This motor previously was an alarm for lubrication 80% of the time during our visits. So, you know, every time we come here, we found that the schedule that the guys were doing here was completely out. And, you know, they even had 2 bearing changes. I mean, this customer's been mine for the whole 6 years of the business. And, you know, we've actually changed the bearings ourselves once on this, down to poor practices of them not lubricating correctly. And since we've taken over, we have seen the life cycle of this asset extend phenomenally. And this is, I think, where the value is, right? Because the problem is with anything reliability wise, when you're doing things well, it's very difficult to measure that you're doing it well, because there's no money behind the fact that it's failed. Do you know what I mean? There's no pain behind the fact that it's not performing. It's just performing. It's just doing its function. But because it is doing its function over a number of years, where's the value in that? There's a massive value in that, especially if it's a key asset that allows you to be able to produce and manufacture the goods that you know, create your profit and your money and your margin. Okay, so looking again, lube factor tremendously high here. Again, the difference here though, what we have found is that acceleration is triggering now. Okay, so it is bad enough now, and as you can see, the lube factor here is at 0.6 or 0.4, which is a lot higher, and it's now starting to trigger the acceleration a little bit as well. But remember, this is at a stage where the lubrication is fairly bad, because really want to be capturing it about this 0.2 region. So we don't want to get into that friction related overall where it becomes actually damaging to the bearing, because there's a stage here where it starts to actually cause wear. Okay, and as you can see, you've got this high haystack here, and this is the haystack that lube factors that kind of, you know, measuring, definitely taken into consideration. That is fairly high. The scale here is a lot higher than last. Here, what you have got is some inverter frequencies present in this frequency spectrum as well, which is making the overall acceleration fairly high. So this is, again, very important why we banned out these areas. So, you know, lubrication factors, purely looking at lubrication events, not anything else. Okay. Afterwards, as you can see, inverter frequency is still present. You know, if you have a look at that, they're still there. They're still present. But if you have a look at around this frequency range here, these haystacks have completely disappeared. So again, if you have a look at lube factor and the motor non-driving as well, as you can see, 0.05, 0.09, very low, going from 0.3, 0.3, 0.6, 0.42, extremely high readings to very low readings. And if we have a look again, here is the difference in terms of readings. You can see again that the inverter frequencies, and it's very odd that the inverter frequency is actually fallen as well, which I don't know the answers to that, but very interesting one. But as you can see, these large haystacks that were appearing, and as you start to get worse lubrication, it'll start to move lower down the spectrum. So this is why it's quite important as well to capture these events earlier, because again, it can cause havoc. And the thing is, when your acceleration is an alarm, it may make you think that there's other issues and problems going on. But the fact is, all that's happening is that there's high friction within that bearing causing high acceleration. Okay. So any questions, guys? I'd love to know your questions in terms of what you've got. Write them in the chat. We're kind of at that 31-minute mark. So I think it was 35 minutes. I hope that kind of explains a lot of different, you know, the concept of lubrication factor. If you guys would like to learn more about it, I'm more than happy. Just literally drop me a message. I can show you some case study stuff. We can show you some, you know, we can show you some videos as well. We've actually got some videos of this as well. Unfortunately, I wasn't able to get the videos in time for the presentation because some of the guys love to be able to record themselves. Thank you, Telmo. Really appreciate that. Thank you, Eric, as well, for tuning in. I hope that was really insightful for you guys, and I hope you taking a lot from it. But yeah, again, guys, if you'd like, you know, I am here to be able to be talked to about anything with this lubrication factor reading, anything you guys would like to know or understand about it further. I'm more than happy to be able to show you some case studies, some videos and stuff like that. Any question, guys, if you've got any questions, please leave them in the chat, and I'll be more than happy to answer them. If not, I thank you guys for having me. Honestly, such a pleasure to be here. And yeah, real pleasure just to be involved with reliability in general. Thank you, Charles. I really appreciate that. Really appreciate it. I hope that made sense as well. Really appreciate it. Thank you.
All right, it was very interesting. I also follow it.
Perfect. Yeah, no, thank you for that. I hope it was insightful. Thank you, David. I really appreciate that, David, honestly. And guys, if you have, you know, I'm sure you have got me on LinkedIn, but if you haven't, add me, Will Ocean, and we talk about this stuff all the time. We've got case studies, we've got a podcast, we've got, you know, we're going to start to put together a bit of a forum as well, so we can put this information in as well. We really want to get everyone involved with this, if that makes sense, because what we're trying to do is trying to educate and try to share our knowledge as much as we can, because you know, if we can all work together with reliability, we can create more of a sustainable future for everybody. You know, it's a bigger impact than just, you know, us building our businesses, you know.
Yes. Now, thank you very much, Will, for this beautiful presentation. And for the rest, be sure to follow all the other topics at Lubrication Virtual and Lubrication and Reliability Virtual Summit. All right. Thank you very much.
Thank you, guys. Take care. Pleasure to be here.
Bye-bye.
Bye-bye.